All right, number 10. So this is particle motion. So a particle P moves on the number line shown in part A of the accompanying figure. Part B shows the position of P as a function of time. So we're just doing part A of this question. But when is P moving to the left, to the right, and when is it standing still? So we're going to be looking at left, right, and still. So basically it's moving to the right when it's increasing, it's moving to the left when it's decreasing, and it's still when it's like a flat line that's constant. So we will only include a point if it's actually like a dot in it, okay? So on what interval is it moving to the left? And it could be multiple intervals. So basically from what x value to what x value is it moving left? 2 to 3. So it's going to be 2 is less than t is less than 3. That's the time interval when that's happening. So that's basically it's got a negative slope there. Are there any other times where it's moving left? 5 to 6. Now notice there's an end cap point on 6. So we are going to include that. So it's going to be 5 is less than t is less than or equal to 6. How about right? 0 to 1. And because, is it end capped? Well, because it has a specific starting point at 0, because obviously we can't have negative time, we're going to include 0. Okay, even though it doesn't look like it has an end cap, but that's got to be the initial time, so we're going to include it. So 0 less than or equal to t less than 1. Are there any other times when it's moving right?
No.
Okay, and then when is it standing still? 1 less than t less than 2. Any other ones? 3 to 5. 3 less than t less than 5. And that's all you'd have to do for that. All right, on to 14. This is where we're going to get into some word problems. So, free fall. The equations for free fall near the surfaces of Mars and Jupiter, S in meters, T in seconds, are Mars S equals 1.86 T squared and Jupiter S equals 11.44 T squared. How long would it take a rock falling from rest to reach a velocity of 16.6 meters per second? About 60 kilometers per hour, which we don't need to worry about that, on each planet. So I'm given the position functions for Mars. It is S equals 1.86 T squared. And for Jupiter, S equals 11.44 T squared. So ultimately, I'm looking at velocity. So if I'm given position, how do I get to velocity? And you're not plugging in numbers yet.
Like the displacement over time thing?
No. I'm given a position function. What do I need to do? I take the...
Derivative?
Yes, take the derivative. So the derivative of position is velocity. The derivative of velocity is acceleration. So this one wants velocity. So I'm going to take the derivative of each of these individually. So what would the derivative for Mars be? And I'm going to change this to velocity because the derivative of position is velocity. So I'm now going to call it V.
Wait,
3.72 T. And let's go ahead and do it for Jupiter as well while we're in the mode of doing that.
22.88 T.
Those are my two velocity functions for their respective planets. So now that I have that, it says how long would it take a rock falling from rest to reach a velocity of 16.6 meters per second on each planet? So basically, we're changing V out for 16.6 in both equations and solving for T because we want to know how long it's going to take. So I've got 16.6 is equal to 3.72 times T, and then the other one, 16.6 is equal to 22.88 T. So then in both cases, I'm just dividing by the number that's respective with T. And so T is equal to what for Mars? 4.46, is that what you said?
Yeah.
And don't forget units because we are dealing with something specific. So 4.46 seconds. Gonna note over here that velocity is equal to 16.6. How about for Jupiter? 0.73 seconds. And that's all you have to do for those. So they're word problems, but they're not too bad. All right, let's look at 20. I don't think we're going to look at the entire thing, but we are going to look at a good chunk of it. We're looking at A, B, and C. So 20, it says a particle moves along a line so that its position at any time t is greater than or equal to 0 is given by the function s of t is equal to negative t cubed plus 7t squared minus 14t plus 8, where s is measured in meters and t is in seconds. And so the first thing it wants us to find is the instantaneous velocity. And it wants it at any time t. So that means we don't need the formula. All we need to do for that part is to take the derivative because it's at any time t. Underline that part there. So the derivative of position would be
negative 3t squared plus 14t minus 4.
Yep. And so that's all they need. That is at any time t. Now if they give us a specific time, all we would have to do is plug it in, which I think, well, we'll kind of use that in a minute. But part B then says, find the acceleration of the particle at any time t. So again, because it's just anytime t, it's just generic. So how do I get to acceleration from velocity?
Take the derivative of the velocity.
Yep, take the derivative of velocity, which would be what? A of t equals?
Negative 6t plus 14.
Yep. All right, and then the last part that we're going to do of this problem, part C, says, when is the particle at rest? Any ideas what I might need to do to figure that out? At rest would imply what?
Constant.
What's zero? Velocity. Velocity would have to be zero because I'm trying to figure out when it's at rest. That means time. So I'm going to take my velocity function here and set it equal to 0. And now how might I solve this?
Factoring? No.
If you can factor, absolutely. If you can't, what might another method be? Quadratic formula. So negative b, so negative 14, plus or minus the square root of b squared, so 14 squared, minus 4 times negative 3 times negative 14, all over 2 times negative 3. So somebody take the positive one and somebody take the negative one and figure it out. Huh? All right, Josh has got positive. Somebody take negative, so we don't have to wait 8 years to answer this question. Okay. Something's wrong.
Yeah.
Make sure you pay attention to negative signs inside the radical. And all the other negative signs that are in there.
Do you want us to like put in decimal form?
Yeah, go to just one decimal place is fine.
No, I did negative and got 3.2. So I'm confused.
You did negative and got 3.2?
After I did
Maybe
the
I didn't
negative, I
put
got
zero.
3.2.
I don't know.
Josh, I think you did the positive, or I think you did negative, buddy.
You got 3.2.
Okay. Christian says positive is 1.5.
Let me do positive.
It is.
Those are the two answers. I don't know which one's supposed to produce what, but I clearly see that y'all got both of them, so.
Divided by 2 times 3. Yeah, I got 1.5 for positive.
It's okay. We just don't rely on Josh for anything. I just kidding.
I'm not.
No, since I did the negative and I did get 3.2.
Did you let me see how you're plugging it in. Let me look at your calculator.
You're definitely plugging it in wrong then.
Let me look at your calculator history. Why do you do it like that? No, just plug in all the numbers.
She doing it step by step. That's why.
That's why. Look. You just plug in all the
Parentheses
numbers
are
and
your
use the
friend.
parentheses.
Is your calculator dead, Nathan?
Because you're getting it wrong.
I have a charger.
Do it out.
Because you're doing it wrong.
I mean, if you want to use that, that's fine, but I have a charger.
I think
Let's
it's
see.
Okay.
Alright, let me get it. I'm gonna get it first.
Okay, just plug everything in. I'm just saying.
Give Josh a minute.
Yeah, let's get Josh.
I have a beauty timeout while I fix my hair.
Okay. Doesn't make sense.
You still not plugging it. You get it
No,
wrong.
I got the right answer.
Yeah. You got the right answer because you plugged it all in.
But I did it the same way. We just wrote it out.
Really?
First time we did the same.
Why was it something wrong?
You're definitely doing something wrong.
Well, obviously.
All right, 24.
Stop.
A body's velocity at time t seconds is v equals 2t cubed minus 9t squared plus 12t minus 5 meters per second.
Mm-hmm.
So v of t, or well, I'm gonna say v of t because just v.
Sounds cute.
2t cubed minus 9t squared plus 12t minus 5. Find the body's speed each time the acceleration is 0.
Should we take the
So we
derivative?
have to take the derivative to find the velocity and then take that derivative to find acceleration and then plug it equal it to
Isn't it
0?
already in
This is velocity
Oh,
already.
so we-
Man.
Please don't die, Nathan.
Oh, so take the derivative and then equal it to 0. Or
Yes.
not equal.
Yes.
Okay.
Well, sort of.
No.
We won't be done at that point, but yes, that's what we need to do initially.
Okay.
Okay.
All right, so I need acceleration. So what is acceleration from that?
6t squared minus 18t plus 12.
And we set that equal to 0. Now what can I do?
Oh, wait. Yeah,
I can make my life easier.
Wait. Yeah, we can. Yeah, we can. Yeah, we can. Let's,
What can I do?
We can extract a 6 out of there.
Yes, I can take out a 6, and what's going to happen to it?
It's gonna
Just
go
decrease
away
the number.
Why?
because it's equal to 0 or something.
Yes, because 0 divided by 6 is
This is 0.
0. So I'm going to take a 6
Yeah.
out of everything. t squared minus 3t plus 2 equals 0. So t squared minus 3t plus 2 equals 0. Now what?
Now we can actually do something useful, and
Which would be what?
we can
Factor.
So what is that?
Oh, you gotta give me some. I'm prepared.
There's always going to be a follow-up question.
We're gonna go with
Yes. T minus 1, t minus 2. So that means t is equal to?
1 and 2.
T equals 1. T equals 2.
Am I done?
I wish, but probably not.
I wish, but
Find the body's speed each time the acceleration is 0.
So now we have to find its speed.
What do we know about speed?
it does something.
It's not as good as.
It's not as good as velocity.
Yeah, just get it.
Okay, so what do I need to do when I get my answer?
Absolute value of velocity.
It has to be positive.
It's got to be positive, so I got to take the absolute value of it if the number should happen to be negative. So now, at t equals 1 and t equals 2, I'm going to use those numbers in my velocity equation
Like, just plug
and find the velocity at those times. AKA find the speed. If it's negative, I need to make it absolute value. It's got to be positive. If it's already positive, it doesn't really matter. So, come back. V of 1 is equal to 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 minus 5. So 2 minus 9 plus 12 minus 5 is
0.
0.
0.
0 meters per second.
I was getting there.
So that's the first one. So at t equals 1, it's 0 meters per second. And then the other one, we do the same thing, but v of 2. So 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 5. So we've got, what is that, 16 minus 36? Yes.
Something like that.
Plus 24 minus 5 is
Oh. Wait, 39. Wait.
what? Try again. One more time.
-9. Wait.
Try one more time.
Give me-
Somebody help the board
Wait,
boy
no,
out.
no, I
Ethan.
got it.
Ethan's
I
got it.
I
Ethan
got
has got
I
it.
got it.
Ethan, go.
-1.
-1.
39.
Had to put you out of your misery. Now, what's the problem? I want,
No negative.
No negative.
so I need to take the absolute value. So the speed is going to be 1 meter per second.
Yes.
What are you doing?
I'm crying myself to sleep tonight. Crazy.
Please don't. What'd you say?
He said, "Welcome to the club."
Oh. That's so sad.
Yeah. I've been in the club for a while, Nathan.
Josh is the president. Yeah.
Yeah, I have depression, you know.
All right.
I can get scholarships for my depression.
You get scholarships for having red hair.
I don't think I can.
Too bad you're Auburn.
I'm not red enough for that.
Maybe you can get a scholarship to Auburn.
Maybe.
Maybe that would count.
Maybe we can lie to them and say I have red hair.
No, because then all the redheads in the world.
What are they gonna
kill
do?
me.
Make me take a picture of myself?
I mean, I think it's just probably like an honor code. Like, no one's gonna want to be redheaded if they don't have to be.
That was so mean.
True.
What's wrong with redheads?
Depends
All right.
on the redhead.
34. Inflating a balloon. The volume V equals 4/3 pi r cubed of a spherical balloon changes with the radius. Okay, so that's the volume of a sphere, in case you didn't know that.
That would be correct. How you doing?
I did.
At what rate does the volume change with respect to the radius when r equals 2 feet?
What is the question? 34? Let's see.
Should have been paying attention.
Hey, let's think.
So we're just plugging in 2.
Nope.
No. Incorrect.
Would be so
Did we find the derivative?
Yep.
Woo!
Ah!
I was just guessing. based on
So
the other
first
one.
and foremost, take the derivative.
Of course we can.
So derivative of volume with respect to radius, so dv dr. So what is the derivative of v with respect to r?
4 pi r.
Somebody please help him.
Squared.
I was like, you wrote it, but he's wrong. Wait. Well, yesterday when you were trying to just take out the 2 and you had to remove the pi.
2 and pi canceled, didn't y'all know that? Josh did, nobody else did.
Yeah, that secret knowledge no one else has.
Now at 2, 4 pi times 2 squared is
Ew, my pen is, like,
16 pi. And this is the way they write this is weird. Feet cubed per foot. But they write it as, hold on. They write it as cubic feet of volume per foot of radius.
Cubic feet of volume per foot of brick. What is that?
Why are you looking back here?
So this was for r is equal to 2. Then the follow-up question says, by approximately how much does the volume increase when the radius changes from 2 to 2.2 feet? So we need to find at 2.2 feet what it is, and then subtract them. So we would have 4 pi times 2.2 squared, which is what? I actually am going to need a number, so if somebody wants to multiply 16 times pi and tell me what that number is out to like 2 decimal places, that would be great. And then this one out to 2 decimal places, if it should have that many. I don't know if it does or not.
Do you want me to read it for you? This is me answering now.
On Josh's behalf.
60.8.
Does anybody agree?
What do you? What is it?
Huh?
Yeah.
Okay, good. How about 16 pi? What is that?
It's 50.3.
Flat?
Wait, how far do you want?
Just one's fine.
50.3.
Okay.
Not flat.
So now I want to know how much it increases when I go from a radius of 2 to 2.2. So that means I'm going to subtract the two numbers. So 60.8 minus 50.3 is
10.5.
10.5 feet cubed. Now, that answer is slightly different from the book because they round a little differently. They round to like 3 decimal places, which probably makes a little bit of a difference, but that's fine.
I did this. I didn't know what I was trying to say.
So, anyways. Any questions? Sweet. Then your problems are 1, 9, 11. Well, not H. Nope, stop that. 11, A and B. Then 15, 21, 23, 42, and 43. And 42 and 43 are AP type multiple choice questions. They're not hard. But just to give you a little taste of that. Tomorrow we will do the next section